Okay, and welcome to this video on histograms, a topic which you've definitely seen before in GCSE. However, there's a slight twist at A level, which makes it a bit more challenging, but nonetheless, as long as you follow the sort of basic concepts, you'll be fine. So what are histograms? Histograms are a useful way of representing group data with unequal class intervals. Okay. Now, at GCSE, you were told that the area of the bar is equal to the frequency of each class. However, in reality, the area of the bar is actually proportional to the frequency of each class. Okay. Now, that has a little bit of a consequence when we're doing our work in this worksheet. Okay. And the fact that, sorry, let's have a bit of a less thicker pen. In the fact that A therefore is proportional to F frequency, which means if we want to get rid of that proportional symbol, that A is equal to K times F. K is obviously some constant that we will need to think about, okay? And F is obviously the frequency. So that's important going ahead. That area is proportional to frequency, and therefore area is equal to K times F. Now, let's just break this down a bit more. In a histogram, what you normally have is your frequency density on the y-axis, and you normally have your class widths here. Now, obviously, if you just look at this area equals KF formula, if you think about that carefully, the frequency density is your y, your class width is, your x. So if you were to multiply through by the class width, you'd have the area on the left-hand side and K times frequency here. So this formula goes, they sort of complement each other, both of these sorts of things. Okay. Now, as I said, at GCSE, you were told categorically that frequency density is frequency over class width. Obviously, the fact that they're actually proportional, area and proportional to frequency, means that K will have a bearing on this. A frequency polygon is drawn by joining up midpoints at the top of the bars. It's not a big concern though in the A-level course. Okay, so question 1, the histogram shows the relationship between the cars, number of cars, and the fuel efficiency of these cars. There are 34 cars shown in total in this histogram below. That's important. That's the total frequency of all these bars, if you were to sort of think about that. So question 1A, how many cars are there in the 15 to 20 class? So if you think about this first, they're asking for frequency. So they're asking for frequency, and if they're asking for frequency, it would be good if we can find the area. Okay, so 15 to 20, that's this bar here. Okay, now what we do know is that all the bars added up equal 34. Okay, so let's use that information and let's try and find the total area of all the bars. Now, this is not very difficult stuff. It's very basic mathematics. So the area of this bar, that'll be 5 times 1. Area of this bar, that will be 5 times 2. And if you add up all these areas, 15 to 20, that's 5 times 4, 20. What you'll get is a total area of 85 graphical units. Now, if you remember, area is equal to KF. So this area of 85, that's equal to K times by the frequency. And now the frequency is the total frequency that we know in this situation. So that's 34. Now what we've got is the value of K, which will make this question a lot easier for us. The value of K is 2.5. And once I've got 2.5, the rest of this question should be fairly straightforward. Okay, how many cars are there in the 15 to 20 class? So let's just zone in on this class here. Okay. So if I know this class, if I look at this a bit more detail, then I can use this formula here. Or if I can sort of think about area, just immediately I can use this formula again. So area equals KF. Now the area of this bar is 5 times 4, which is 20. And that's equal to KF, 2.5 times F. Yeah. And if you rearrange that, you get a value of the frequency to be equal to 8. So there are 8 cars in the class 15 to 20. So let's just recap this. You were given total information. You're given information about a total number of cars of all these blocks added up. So it was important for us to get the value of K, which is important because the area is proportional to the frequency. Okay, once you've got the value of K, by adding up all the area, getting into equal to 85, making that equal to K times 34, got the value of 2.5, I can apply that to any of these bars here. So again, this area is 20, and that's equal to 2.5F, which means that the frequency is equal to 8. That's part A done. Part B, estimate the number of cars with the miles per gallon in the 17 to 33 range. So I'm just going to rub all this out here. Now 17 to 33, let's just imagine that 17 is here and 33 is here. Okay. Estimate the number of cars with the miles per gallon in that range. So again, this is a frequency question. I'm just going to put part C here. It's not part C in the document. So again, it's a frequency question. We've got to estimate. So let's try and think about the total area that we've got here. Now again, we've got a little bar here between 17 and 20. Okay, so I'm going to rub out. Actually, I think we've got a bit of. Rub this out here. Okay. So I've got 17 to 20. That's going to be, width of 3 times 4. That's 12. Then I've got 20 to 25. That's a width of 5 times 4. That's 20. Then I've got 25 to 30, width of 5 times 2, which is 10. Then I've got 30 to 33. That's a width of 3 times by 2, which is 6. Now, if I add that all up, I'm going to get a total area for that section to be 48. Now, again, if you remember, that area is equal to KF. So that is equal to 2.5 times F, which means that obviously F is equal to, again, this is an approximation, 19.2 cars. Okay. So again, I'm just using the formula here and just trying to get the area. Now, final question in question 1, part C. There's one car missing which had an MPG of 47. Complete the histogram. So MPG, remember, is the x-axis. So essentially, if it's got an MPG of 47, there's a bar missing in this class interval. Yeah, in this class width, 45 to 50. Now they've told us what the frequency is. Yeah, that's important. They've told you what the frequency is. Okay, it's 1. Now we've got to construct this bar, and we've got to bear in mind that its frequency is 1 and the class width is 5. Okay, so let's just think about this carefully. Now, again, if I had to think about it in a bit more detail, what would the area be? Remember, the area is equal to K times F. So it will be 2.5, which is our K, times by the frequency. There's only one car in the interval. So what we've got to do is construct a bar which has an area of 2.5. Now, if we think about this carefully, we know that the width of this bar is 5. What must the height be in order to give a total area of 2.5? If you think about it a little bit carefully, it's just got to be a half. So this bar is going to be half up from the x-axis. Yeah, because the 5 times by half will give you an area of 2.5, which will represent the one car. Okay, so that's question 1, and it wasn't extremely tricky, but again, we're just using the concepts here. Okay, right, question 2 is actually a bit more work associated with this. So in question 2, the number of patients attending a hospital trauma clinic each day was recorded over several months, given the data below. Now, we've got 10 to 19, 20 to 29, 30 to 34. So these are the number of patients, these are the classes, and these are the frequency in those class widths. Okay, so there are 2 patients, sorry, the number of patients, or the number of times there were patients between 10 and 19 of them. There were two instances of that. Okay, 18 instances of 20 to 29 patients, 24 instances, etc., etc. Now, one thing we have to remember is that these class intervals are not overlapping. So we've got to understand what the real class intervals will be. Now, this class interval will be 9.5 to 19.5. Okay, and likewise, that'll be 19.5 to 29.5. Okay, so that's where we've got to make sure that in our histogram, we're not going to draw a histogram, but if we were to draw one, that's what we have to consider the overlapping nature of that. Okay, because these are unequal at the moment. So 29.5 to 34.5, etc. Okay, right. These data are presented by the histogram. You're told that a bar representing the 20 to 29 group is 2 centimeters wide and 7.2 centimeters high. So given that information, we've got to calculate the dimensions of these bars in obviously centimeters. So we've got to find the width and height of these centimeters, of these bars in centimeters. A bit more challenging, this question. So let's imagine this situation here. Okay. So if I'm just using the information given to us, given that bar representing 20 to 29 is 2 centimeters wide by 7.2 centimeters high, well, where's the 20 to 29 information? That's here. And I know that the real class interval is 19.5 to 29.5. Okay, so let's think about the area of this bar. Now, the area of this bar in real, centimeters would be 2 times 7.2. Now, if you think about that, or you just use a calculator, you get an area of 14.4. Now, again, you're told, well, you know this, that the area is equal to K times F. And you know the frequency in that bar is 18. So if you solve to get the value of K, that'll be very helpful for us going ahead. Okay, so we're going to get a value of K to be 0.8. So using this information, let's try and think about the situation going ahead. So the area of each of these bars will be 0.8 times F. Now we've got all frequencies here, so that would be good for us. So for part A, 30 to 34. Now, if you think about 30 to 34, that class width isn't actually 4. That class width is actually 5 because it starts from 29.5 and goes to 34.5. So that class width is 5. And its frequency is 24. Now, remember, what would the area be? If I use this little formula here, the area will be 0.8 times by the frequency. What do you get? 19.2. So what we've got to do now is construct a bar which has an area of 19.2 centimeters. And we've got to think about the information given to us previously. So if you think about this bar here, this 20 to 29 bar, this has actually got a class width of 10. So this class width was actually 10, and it's represented by 2 centimeters. Now this class width for part A, which is 30 to 34, that class width is actually 5. So if the class width of 10 gave a real dimension of 2 centimeters of width, a class width of 5 will give 1 centimeter of width. Okay. And if you're going to have 1 centimeter of width and you need to construct a bar 19.2 centimeters squared with that area of 19.2 centimeters squared, then it's got to be 19.2 centimeters high. Okay. So let's just recap that again. In this question, we're trying to find the real dimensions of this 30 to 34 bar. In the class width terms, it's actually 5, it's not 4. Okay, so in that case, class width is 5, frequency is 24, and if I use this formula, the area in centimeters squared should be 0.8 times 24, 19.2 centimeters squared. We've got to construct that area. We know that a class width of 10 from the information given to us for the 20 to 29 bar, that class width is actually 2 centimeters across. So that means a class width of 5 will give 1 centimeter across and therefore 19.2 centimeter high. Now for part B, 50 to 69. Now if I go all the way to 50 to 69, the bar will actually start from 49.5 and go all the way to 69.5. Now that class width is actually going to be 20, not 19. The frequency is 5. There are 5 people in that, or the number of instances of that is 5. Now again, let's try and find the area. So 0.8 times by 5, which is 4. So we've got to construct a bar which is 4 centimeters squared in area. Now again, let's look at the information given to us previously. A class width of 10 gives a rectangle 2 centimeters wide, or bar 2 centimeters wide. Here we've got class width of 20. So the bar will be double. It'll be 4 centimeters wide. Now remember, we just got to construct a bar with an area of 4 centimeters squared. We know what the width is, it's 4, so the height must be 1. HT for height. Okay, so that's histograms in a nutshell. And again, all I've been using was the fact that area is proportional to frequency, therefore A is equal to KF. It's very useful to try and find areas of bars and obviously make that equal to KF. And likewise, questions like this where they've got real life dimensions, trying to pick apart the information they're given to you and trying to understand how we're going to use that information. So here's some questions here, page 50 in the Brown textbook, questions 1 to 5, exercise 3D, and some stretching challenge questions as well. That's the end of this video, and look forward to seeing you in another stats video.